Hello, this is Felix on GMWolf, and welcome back to building a car game. Today we're going to be adding some skidding to our car to make it more realistic and a lot more fun. Now, how are we going to do this? First of all, let's consider our tire and the floor. So here is our floor, and our tire may look something like so. Here you go. Now, we have a few forces acting upon that tire, the first one being its weight. We also have the reaction force from the floor against the tire, call it R, and we finally have maybe the force which is currently withstanding because of its turning, which we're going to call F, and we also have the friction force, which is from the tire against the floor, which I'm going to take another color for, and it's going to be going that way. So let's call this one F for force friction, or friction force. First of all, we have to determine what this R value is here. Now, the reaction force has to outweigh the weight force, so it will be equal to the weight force, otherwise the tire would be either going down into the floor or up into the sky. So the way we determine this is that R is equal to the weight of the tire plus a quarter of the weight of the car. Now, the reason why we add a quarter of the weight of the car is that the car isn't really resting on the floor. It's actually resting on the tires. And roughly speaking, for now, we can say that a quarter of the car's mass is going on each tire, of the car's weight, sorry. Now we have to determine what these two forces are here. So this force F is the force that is being acted on the tire to stop it from moving. So we always know where it is. It's a variable. It always changes. We can't write a value for it. We already have it inside our program. However, now we need to calculate what FF is. So first of all, you should know that when two surfaces are in contact, they have friction, and the way you know how much how much friction there is by using the coefficient of friction. So this is generally noted like so, as a mu, and with asphalt in a tire, it's around 0.8. Now, when the tire is actually skidding, this goes down to 0.6, which is why when a car will start skidding, sorry, it doesn't do so gradually. It will start all in one go. Now, to find this friction force, then it will be equal. Well, the maximum friction force, so FF max, will be equal to mu R. So mu being the coefficient of friction and R being the resistive force over here. So what this means is that if this force here, F, the force we're putting on the tire, gets greater than F max, the friction force will only be equal to mu R. If it gets lower, it will be equal to, well, it will just be equal to that. So this tire will only start skidding once this force here is greater than mu R. So let's see how we can add this within GameMaker. So here we have GameMaker, and we have our old project we were working on last time. First of all, we need to open up the tire and define a few variables. So let's add an event and a create event. We just want to define... why is this not working? Here you go. For some reason, it's not letting me add my variables. Let me try this again. That's interesting. Let me close this, open it up again, and add the create event. Here you go. It's working again. No, it's not letting me add the create event. Oh well, let me restart GameMaker and be right back. Alright, so we have the create event and a piece of code in, and we just want to say whether we're skidding or not. So when the car starts off, it's probably not skidding. So skidding is equal to 0. For now, this is all we're going to define. We might have to define a few later on. So let's go into the step event and open up the code we were working on last time. First of all, what we want to do is find the magnitude of our lateral velocities. So the way we're going to do that is call LV is equal to the square root of the square of LVX plus the square of LVY. And this is supposed to be a plus sign of LVY, like so. So this is just Pythagoras over here. And this is LV will be our new lateral velocity magnitude. We're just going to leave it as LV rather than LVM because it's a lot easier that way. Now what we need to do is check what kind of force we're going to need. So the force we'll need will be our lateral velocity times our physics mass. And what we need to do is store this inside a new variable we're going to be calling L force for lateral force. So L force is equal to LV times physics mass. What we need to do now is check whether this lateral force will be greater than our maximum friction force. So before we do any of that, we need to calculate what our maximum friction force is. So the way to do this is quite simple. First of all, we check whether we're skidding or not. So if skidding, and we say if we're skidding, our force max, so max, or force max, let's say max F, will be equal to our mass, which will be actually it's more of a resistive force, which will be physics mass times 9.8, actually 10 because we're using box 2D and 10 is the value for gravity, and we're going to add the car's physics mass, so obj underscore car dot physics mass times 10. But we only want a quarter of the mass of the car, so we're going to be dividing that by 4 because the car is resting on the tires. So now that we have our thing, we need to times that by 0.6 because remember, when we're skidding, you're really only having 0.6 of a coefficient of friction, and we're going to times all that like so. So double brackets, physics mass times 10, close brackets, plus double brackets, obj car dot physics mass times 10, close brackets, divided by 4, double close brackets times 6. I hope this is visible on your screen. So now what we're going to do is just copy that, put an else statement, and change that to 0.8. So if we're not skidding, we have 0.8 rather than 0.6. Now we have to check whether our lateral force exceeds our max F. So if L force is greater than max F, we want our lateral force to be equal to max F. However, we're not going to store that in lateral force. We're going to call that neolateral force, so NL force, because we might need our lateral force later on when we add sound and whatnot. So neolateral force is equal to max F. Otherwise, if L force does not exceed max F, sorry, we're going to say that NL force is equal to L force. So I hope you don't get confused with all these different similar sounding variables. I'm trying to be as clear but concise as possible. Now that we defined our L force, etc., we need to readjust our LVX values and LVY values. So what we have to do is normalize this vector LVY AVX and times it by our new NL force. The way we're going to do that is simply dividing them by the LV force here. So LVX divided is equal to LV, and LVY divided is equal to LV. Now we have a small problem, is that if our lateral velocity is 0, we'll have a division by 0 error. So let's just add a new if statement. If LV is equal to 0, we're just going to set LVX and LVY to 0. This is equal to 0. And then, otherwise, if it's not equal to 0, we can do our calculation. So now that we adjusted our LVX and LVY to a length of 1, we just need to times LVX and LVY by NL force, and LVY times is equal to NL force. So this should work with our current setup unless I goofed up somewhere. So let me quickly check if it works and I'll be right back. So very small adjustment actually. Here where it says physics apply impulse, we are multiplying LVX and LVY by physics mass. However, we already done so under our L force variable up here. So all we have to do down here is simply take off the times physics mass. Now if we run the game now, after saving, we should see that if we turn gently, the car behaves as expected. And I know the video may be a little choppy, but you should be able to see better. But if I start turning a lot, you can definitely see that your tires are skidding quite a lot. So that is a lot more realistic in that respect, and will add a lot to the game, especially once we add sound, collisions, and even there's tons of possibilities with skidding. You can add some skid marks on the floor, etc. So now we still have a few more things to add. This video may be a little long because of how much there is to add friction with the tires. And if we open this sprite here, you can notice I created 2 new sprites. The first here one on top is a ice sprite, where if you go over, you won't have much friction at all, maybe 0.1 or something like that, whether you're skidding or not. So that can be a little fun if you're making more of an arcade kind of game. But if you're making a racing game, it might not be too useful. And the second one is a concrete sprite, which is more like asphalt, where your friction will be higher. So maybe you could make a road out of it. Now obviously we're not going to be using this system in the final thing. However, it will provide a really good basis to add our more complicated systems later on. So what we're going to do is first of all create a new object under this tab here. We're going to choose the concrete and name it obj_concrete, or conc for short. Press OK and create a new object as well. Call it obj_ice, and obviously choose the ice sprite. Now what we're going to do under obj tire is add a very small bit of code, not too small, but quite powerful actually. We're going to be using a switch statement so that you can add as many different materials as you like to skid on. So if you don't know how the switch statement works, you basically provide a statement or an expression really, and it will get a value out of that, and it will go between all the different cases, checking whether it is that case, and then executing the code which is in it. I'll show you right now how it works. So we're going to switch between this function. We're going to be using collision_point, which returns collision point will basically make check exactly underneath the point you provide and check if there's a collision. If so, it will return the ID of that object. So we're going to check at x and y. Obj, we're going to do par_surface, and we will have to create an object later on. Precision, why not? Doesn't matter, but 0. And not me is true. Next, we want to add these brackets here and add the first case. So case 1 will be, well actually before I do that, we do have to add a small thing here, .obj_index, object index, sorry. So this will get the object index of the collision. Actually that may be problematic, because it will only work if it does return a collision. So apologies here, we do have to cut this code out and paste it here and say I is equal to that, and go if I is not, if instance exists, I then do the switch statement, like so. I hope you can follow this. I didn't quite think that one through. So basically what we're doing is setting the collision to I, so whatever is underneath. Then we see if I is an object, if it exists, if there is something below the tire, we're going to switch between I dot object index, and if I dot object index is obj underscore conc, then we put a colon and you write, let's call this mu, let's call it mue is equal to 0. Let's call this 1 actually, or even higher, 1.2 would be good. And then you need to break it, otherwise it will follow through and go to the next ones. Case obj underscore ice mu is equal to maybe 0.1. You want something really, really low, and then break. What we're going to do now is over here times everything by mu, and over here times everything by mu. Now the problem we'll have here is that if you don't have obj conc or obj ice underneath your tire, mu will not have a value. So up here above the I is equal to collision point, we're just going to write mu is equal to 1. Actually, let's do lower because it is grass, 0.8. So let's press OK here and open the room, just so we can test things out. So let's stretch this out a little and take our obj concrete, put one here, put one here. If you zoom out, you can even stretch them for them to be longer. Well, here you go, just have to refresh it a bit. And let's add another one maybe here, just so we can try stuff out, and then put some ice sheets over here so we can see what happens. See if we can get some nice skidding of the ice, which may be quite enjoyable depending on your type of game. Now, hopefully this will run, so I'll be back when it finishes compiling. Now, of course, we did forget to do something. That would be to create the par underscore surface object. So here it is created. So just create a new object and call it par surface. Uncheck visible because we don't need it. Press OK. And now go under obj conc. Under the parent section, choose par surface. And under the ice surface, check par surface as well. This way, our collisions will check both for obj conc and obj ice. Now, the problem we may have right now is, as you can see, we can't see our tires anymore because our depth ordering has not been optimized. However, you can see that we have a very nice traction on the concrete. However, if I move over to the ice, I should have no friction at all. And as you can see, I seem to be skidding a lot more on the ice and a lot less over here. So if I try to enter the ice section like so, we do skid a lot more on the ice. It is very hard to control yourself on the ice. It's maybe not too visible on the video because of the choppiness. However, you can feel it if you play the game. So this is all for now. We will be adding some more features later on. For example, we will be adding some obstacles and adding maybe better graphics to the game. We will go 3D eventually, unless because Game Maker has not been made for 3D. So I have been holding off the 3D aspect for now because it is slightly flawed. But I do plan on bringing this to the 3D level for the people who want to later on in the series. So thank you guys for watching. Please like and subscribe if you enjoyed this video. If you have any suggestions, please comment below, or if you just want to comment without any suggestions, that's also perfectly fine. I've been Felix, and I'll see you guys next time.